Sorry for the delay here. So today we're going to do some number property stuff. Specifically, we talked about divisibility. Now, divisibility is an interesting topic on the current version of the GMAT because, I think a lot has changed as far as divisibility is concerned. I remember a lot of divisibility came in pure math data sufficiency, and now there's no more pure math data sufficiency. So what they've done in certain cases is they have turned these into word problems. They've done more problem-solving data sufficiency questions. So there's a lot of different stuff that they've kind of had to adjust to, change things up for the sake of divisibility questions, which I still think are a big part of the GMAT. So what I want to do today is go through some different ways that they can test that. We'll do about, 25 minutes of questions and then do some Q&A around there or something. So let's jump in. I'll be putting questions up. You guys put your answers here in the chat box. Let me put the first question up and then we'll go from there. All right, so let's see, we've got so a bunch of good answers coming in. All right, so what you need to do here, there's a couple different ways to do it. If you break down 150K into primes, you get 1, 15, and 10, 5, 3, 5, 2, so 2 to the 1, 3 to the 1, 5 to the 2. And then you need to know, so K is the missing link, right? So if you break 100 down, for example, that's 5 to the 2, 2 to the 2, 18 is 3 to the 2, 2 to the 1, and 8 is 2 to the 3. So it's like, well, what's missing if you were to divide things into it? Well, you're missing, you've got 1, 2 here, you have 1, 2 here, but the fact is you need 2 more 2s. So that's where 2 to the 2 comes in. How many 3s do we have? We have 1, 3, but you see we need 1 more 3 for this division to work. So K has to be the extra 3. We're covered on our 5s because the most 5s we have here is 5 to the 2. Notice we have 5 to the 2 here. So 2 to the 2 times 3 to the 1 just ends up giving us 12. So the answer is, of course, D. All right, let's keep moving here. All right, so I see some good answers here. So this is another LCM type question, right? So what we have here is something's divisible by both 12 and 100. The move, you're going to make here is you're going to try to figure out what the LCM is of 12 and 100. Now, there's different ways you can do that. Sometimes I use prime factorization. Sometimes I don't. It really just depends on, what I think the best process is in getting where I need to get as far as the question is concerned based on the numbers. So 12 and 100, like right off the bat, do I think that I could come up with the LCM without cycling through numbers? Probably not. So instead, what I do is I actually do the primes out. So 2 to the 2, 3 to the 1, 2 to the 2, 5 to the 2, and then it just becomes, it's clear, 2 to the 2 times 3 to the 1 times 5 to the 2. So the easiest way to deal with that is 5 to the 2 times 2 is 100. So then you just have this. So, yeah, I mean, you could also just, if you wanted to, you could, adjust. You could go through the answer choices, but I think sometimes that's a little bit more trouble than it's actually worth, to be honest. All right, here's another one, but this is similar, but this is now we're talking about the product of two numbers, which changes things. All right, so the difference here is this is saying what A times B must be divisible by, which is much different than just dealing with LCMs per se. So the thing is, in this particular instance, we know A at a minimum is divisible by 60 and B at a minimum is divisible by 35. And then what's happening is we have to, basically we can multiply them together to see what the minimum value that would be divided by is, right? And there's different ways to do it. I mean, you can basically prime factor the answer choices if you want. I wouldn't necessarily say you multiply these together. So what I would do is I would leave it like 60 times 35. And then I would individually reduce down rather than going the prime factor route, because I think reducing is quicker than priming, to figure out what divides into what. So you've got 60 times 35 here. So like for the first one, for example, it's clear it works, but if you want to do it out, 5 goes into 25, 5 times it goes into the 7, and then 5 reduces with this to make 12. So that one's good. And then you look at Roman numeral 2, and you say, okay, how about 28? Okay, well, 7 goes into 28 4 times, 7 goes into this 5 times, 4 into 60 15 times. Okay, Roman numeral 2 checks out. Roman numeral 3, 5 goes into 48 times, 5 goes into 35 7 times, 4 goes into 8 twice, 4 goes into this 15 times. There's still a 2 in the denominator, so it's not going to work. So 1 and 2 is the answer. So again, you can get there different ways, but that's, to me, a clean, nice, simple way to get to that place. Now, other types of divisibility stuff. In this next question I'm going to give you, this is something that they used to kind of do more in data sufficiency, but they can't anymore. So now they're kind of putting this stuff in problem-solving questions, basically. Why is 25 working here? Because 25 breaks up into 2 5s. You have a 5 that goes into 60 and a 5 that goes into 35. This is exactly why prime factoring isn't worth it, in my opinion. It's not needed. Prime factoring here is precise, but it's time-consuming, and it's adding elements that are going to make things complicated. So I would much rather just reduce down my numerator and denominator and then call it a day. All right. Let's go here. We'll do a couple more questions, maybe 1 or 2 more, and then we can just chat. All right, so a question like this, you know, the trap here, the trap answer would be 216, of course, which they can easily give this type of question where you think, oh, 216 doesn't divide into 60, so that's to divide into Q, but it's not there. But the move here is reducing. And you just be strategic, like 2 goes into 60 30 times. And again, this is more me reducing the way that I think is most efficient. Then you get 108. So that's 30Q over 108. You can do the same thing. That becomes 15 over 54, right? And then I'm pretty sure, yeah, 3 goes into 15 5 times, 3 goes into 54 18 times, and then that's it. 5Q over 18. Now I made a mistake doing math in my head here because let me just see if I can find that. The mistake. Let me go back to where we were. So we have 108Q over, 108's on the bottom, over 30. Well, actually, if it's divisible by 18, then technically it has to be divisible by 9. So as a matter of fact, I don't think actually this is good. So what we end up with here, yeah, is 5Q over 18. Yeah, this is fine. So this actually is a little wrinkle. So because it's divisible by 18, it's divisible by all factors of 18. Notice the only factor of 18 here is, in fact, 9. So yes, that's where we're at with this question here. All right, so anyway, that's a way that they like to mess with you in divisibility. Now, one quick note, and we will end on this question here. This is an important note. When you're doing remainders, and I repeat, put this on a flashcard, whatever it is, when you're doing remainders, you cannot reduce. There's no part of you that can reduce and then come up with the remainder. So if you have, and the reason people make this mistake is because they think about fractions. But if you have 12 over 8 and you need a remainder, that's a remainder of 4. You can't say that that's the equivalent of 3 over 2, so it's a remainder of 1. The reason why people do that is because of the stinking fraction sign. But I promise you, if you were in middle school or high school and you had 12 divided by 8, you're not reducing. If you had 12 division sign 8, you're not reducing. So don't let the fraction sign throw you off here, right? Don't let that happen. So that's important. All right, we can end here. Does anyone have any questions, general study questions, anything they wanted to chat about in general?